Welcome to another code conversation. My name is Philip from Real Python, and joining me today is Martin.
Hi, everyone.
We got a question in our office hours session, and we will tackle the question itself at some point. But we thought that first it might make sense to tackle the topic of how to ask questions online and what's a good way to change your code and update your code to actually get answers that you want to get. So we will kind of transition through this course by first talk about the code itself, then the question, and then go into the refactoring. And in the end, finally answer the question. We thought it might be interesting to take you along with this ride and not just present you a refactoring, but also talk a little bit about our first impression. And this would be actually my segue into the conversation with you, Martin. So what's your first impression of this code? When you saw this code the first time, what are your thoughts about it?
When I look at this at the first time, it was a little confusing. There seems to be quite a bit of unnecessary code, and then also maybe not exactly the necessary code. Also, when connecting it to the question, which we're going to talk about in a bit, it was a little hard to understand how the code that we see here is related to the question, I guess. Another thing is that the code currently actually wouldn't run. And I can see that right away by just looking at this squiggly red lines here. Pylance is telling me that there's a problem here. Predictions or preds is not defined. So the code doesn't look very accessible to me. There's a lot going on. It seems like maybe not the essentials are happening. And I can't just put it into my interpreter and run it to see what the output is, which in an ideal case would help me better understand what is the person asking with their question and what is the issue that they're running into. So it's not an ideal thing to get a code like this. And I think what we're going to explore in this code conversation too is like, what's the work that needs to be done on the side of someone answering this question if they get a code example that isn't somewhat prepared to be answered, you know?
Exactly. Yeah, because you want to make it as easy as possible for a person to understand your code and give you an answer. And all the obstacles that a possible future helper might do to help you might be an obstacle too much. And the person is like, okay, I don't want to even like understand the code first to give an answer. So yeah, to make it as easy as possible, you want to remove the obstacles. And basically, we already did one thing. So imagine like this code that you're seeing there is part of a bigger code base. And by taking this code out and posting it into a new file here in VS Code, we can already see that there is this wiggly line in line 25 where your editor is saying like, hey, something is not okay here. And if you post this code then into Slack, for example, in our help community, or if you post your question on Stack Overflow, maybe the person who helps you will copy and paste the code the same way. And if you then see, well, actually, there are some errors here, this might be one of those obstacles we were talking about where the person is like, yeah, I'm not fixing your code first to actually get to your question.
Unless, of course, the specific error that you're getting is the question that you have, then there would be an error in your code. That makes sense, of course. But in this case, this error here of the variable not being defined on line 25, that isn't actually related to the question. So like Philip just said, you'd have to dig through something to get to the actual problem. Solve some problems to get to the actual problem that the question is about.
Exactly.
One thought I had about the code base, like you described, it was clearly part of some larger code base. And something that the person here did well is to already abstract away some of the details that were probably part of the original code. And you can see that in line 5 and line 12, they're using the ellipsis. And here on line 24, again, to just indicate that there's some code in there, but it's not really relevant to the question. So they cut it out and just replaced it with an ellipsis. And that's a good idea. It might not be necessary to show that there's something left out if you actually refactor your code to a degree that it's this minimal reproducible example, which we're going to aim for in the course of this course. But yeah, so this is a good way to reduce visual clutter if you want to do something quick and just cut out something. But you got to take care that it's then still running, which with the undefined variable in line 25 isn't the case here.
Yeah. And I think you already had a good segue into the next part is like, unless this is part of your question to fix this, to need a solution for it, it's good to not have errors in your code. And I would say like, yeah, let's hop into the next part where we actually have a look at the question now that we had a look at the code. Let's see what the question is actually about.
Great.
Okay, so we had a first impression of the code before, and now let's take a first look at the question itself. Maybe you can give us your thoughts there, Martin.
I think the person asking the question actually prepared this part quite well. The question is part of the file. It's up top. It's nicely formatted. It's easily readable. And also like this overall presentation of you have the question on top and then the code right under is a nice way to go. It makes it pretty accessible. I just need to copy this whole thing and have everything that I need in view, basically. And then also when I read over the question, I think it's quite well formulated. Let's read it out.
Mm-hmm.
How can I make sure that the exception messages of exceptions that occur in the subfunction load models show up in the stack trace of the main function predict draw? So they're even doing things like using backticks from Markdown syntax to indicate that they're talking about a function here, which it's not going to render in a Python code comment, but still, if you're used to writing Markdown, it's still going to help you have a quick visual idea that this is a function that they're talking about.
Mm-hmm.
And yeah, I think the question is well formulated overall. I don't have much to say about it, I guess. Maybe there's some terminology that could be improved. Like here, they're talking about a subfunction and then a main function, which I guess isn't really such a thing in Python. Those are both equal functions here, load model and predict draw. And there's just, you have a caller function, in this case, that would be predict draw, that calls another function. And that's the called function here. That's load model. So those might be better terms to use in here than subfunction and main function, but it's still understandable what they're asking about. So I think the question overall is good.
Yeah.
Maybe the names of the functions is something that we're going to get back to in the refactoring. They could be a little bit more generic. Predict draw, for example, here is more confusing to me than helpful, that this function here is called predict draw. That seems like a leftover from the code base that the person could have refactored out before actually posting this question, I would say. And I think that's something that we're going to do pretty soon.
Yeah.
What about right away?
Yeah, I mean, let's tackle this one right here. So how would you name predict draw then to update the question with a correct function name?
I would just call this the main function, I guess. So I'm just going to say this is the main function, which is also like how the person described it here. Let's just call it main because that is just a generic term of this is going to be the main function that's going to call some other functions too. And calling this function main is just a convention, but most Python developers are going to know what you're talking about when you name it like that.
Exactly. And you just did something very interesting as well, which I think improves the question a little bit. You put the parentheses behind main, and I think you can do the same with load models in line 2 at the end.
Nice. Yeah. And we're going to fix a little typo.
Oh,
It
true.
looks like it's load model in line 7 where the function gets defined. So yeah,
that's a very good spot. Yeah, because with those parentheses, if you show this to another Python developer, they will see right away, okay, so it's about a callable right there. While without them, it could be a variable name as well. So this is kind of giving a little visual hint to your code as well. And everything that's helping your helper is helping you in the end. So that's a good thing.
Lots of help in there.
Lots of help, yeah, because that's what it's about, right? Like you want help. Which brings me to another point of this question before we wrap this up. One thing where you should be clear about is when you post a question online is what is the kind of help you want to have? And there could be two things that come into my mind. So one is you have a problem and you just want to have a solution to your problem, basically fixing your code. What can you do to fix your code? And the other thing is to understand why your code isn't working. And this might be different things. So in the second case, you might not want to have a fixed code. You want to fix it on your own later, but you want to understand why it's not working. And the keywords here are how and why. If you state your question with a how at the beginning, you probably are looking for help in how to fix your code. You want to ideally have a person giving you a explanation of what changes you need to do to make it work, or maybe even some code examples. But maybe you don't want to know so much about the why behind it. And this would be for the second part. If you start a question with a why, you might not be interested in actual code fixes, but more understanding the underneath. In this case, we have an how. Yeah, so this brings us to the next section of how can we make this work?
Let's start to actually do some changes to the code, right?
Exactly. So far, we have looked at the code itself, our first impression, and the first impression of the question, which started with a how. So we try to focus more on improvements that we can do on the code itself to make it work. And maybe we can start with running the code like it is right now and then going into the cleanup. What do you think, Martin?
That sounds good. We mentioned already before that Pylance tells us that they're like an undefined variable. You might expect that there's going to be an error here. So if I run the original file, there's currently nothing happening, which is just because in the code snippet that we got here, there's no function call. So Python just defines these two functions, but doesn't actually run any code. But if I would now go ahead and call main, you see that Pylance in line 29 already tells us again that, there's actually two things. It's missing a parameter x.
The main function needs something. And I think that's very good that you're kind of like, you're just hitting an obstacle. You got
Right.
you got this code, you want to help. And then you're like, oh, wait, actually, I have to put something in. So now you have to try to understand what this X is that the main function has there.
Good point. So my thought process was I'm going to run this and I know I'm going to run into an error because of line 25. But I don't even get to that. Like I'm going to run into another error before, which is that main is missing one required positional argument X. And that's just like Philip said, I'm just confronted with a bunch of obstacles to actually get to the point of helping this person with the question. So let's go ahead and try to make this a working example. I'm going to start with keeping the naming of these variables, which this is not a great name and we'll refactor it later. But for now, I just want to get it to work.
Yeah.
And so I need to figure out what is X, right? So I need to look into this code and see where is it used. And in that case, it looks like it's a dictionary structure where the person is performing some lookup on two keys, S and T, which means that I'm going to here have to have a dictionary that has, let's say, S, and that points to something. I have no idea what it points to. I'm just going to say 0 and T is going to point to 1.
Mm-hmm.
Like, I don't know what X is. I'm just trying to figure out from the code what is the data structure I need to actually get this to run. Okay, now I'm passing this in as X, and then I can try running it again. And now we're actually not running into any error, so that's good. And why is that? Because load model returns. So
yeah, that's going into the more details of the code. So one thing that happens here in line 22 is you're starting with a try statement, and you're catching the exception in line 26, like any exception basically. So my guess would be if anything in this code now throws an exception, we won't see it because it's in this try except block.
Nice. What we can see here is also like that if you use this very general exception, you catch all of the exceptions. So what we ran into now is that this person is probably trying to catch some of these exceptions that are happening inside of load model, but it's also catching the exception that's raised here, that you have like an undefined variable. So we don't even come to this error, but it's still a problem in the code, basically, that makes it not run the way that we would want to.
So my suggestion here would be that we focus on the load model function and therefore, at least for now, remove the try except from the main and just have the load model call in line 22 and remove the rest for now.
Yeah, because the question is about exceptions and how to see like exceptions bubble up in the stack trace, basically, that if an exception occurs in a called function, that it would also show up in the stack trace, like inside of the calling function, is kind of like what this person is asking about. So we don't really want to catch the exception here, right? And like Philip suggested, so let's just get rid of this try and except for now.
Exactly.
And move this in. And then this predictions, this variable, we don't have it. It doesn't add anything here. So I'm just going to remove it for now.
Yeah.
Now we also have another problem here. Pylons is showing, and I can try run this again. We're running into an error that doesn't really help us much.
Yeah.
But you see, like this is a leftover of the try except block and catching the exception. So there's nothing that this helps us with at the moment. I'm just going to replace it with a little print statement so that we know whether everything runs and then ends up being done.
Yeah, but the type error that you're receiving is that currently in line 22, we try to define tokenizer and model as a return from load model, but load model doesn't return two things.
Right.
So we might just have a load model call there and not assign it to a tokenizer and a model just yet.
Mm-hmm. If we want to unpack this error message here, we've got the keyword here that tells us that it's trying to unpack something, which is happening here on line 22, or it's expecting a returned iterable like a tuple, for example, but it's really just getting a dictionary in this return statements here. Like we have two return statements in load model and both of them return a dictionary. So this unpacking is not going to work. And like Philip suggested, good idea. I'm just going to remove that for now and just keep it as a call, because we're looking at the exceptions in here. So we don't really need to do anything with the return value that anyways doesn't work.
And maybe you can also remove the ellipsis in line 23, although it might be a hint to a helper that there will be more in this main function. But I think for now, it's like, let's keep it as dense as possible.
Mm-hmm.
So before we now go into the load model function and clean up a little bit there, I'm also thinking that line 20, assume this is a Flask API endpoint, might be good information if it has to do with the question. But at this point, we don't really care if it's a Flask project or not. So this comment doesn't add to the question itself. So I would propose to also remove this comment here.
Makes sense, yeah. So we're still cleaning up visual clutter here. Let's get rid of the ellipsis here too.
Mm-hmm.
And we're still fitting everything on one screen. That's nice. Okay, now the main function is a lot smaller. We only have a call to the load model function in here, and then just a print statement that tells us that it's done.
Okay, so now that we cleaned up the main function, before we go deeper into the load model function, let's recap for a moment. The code that we're having right now, we're having code that works, which is a good first step, but still load model is pretty loaded. And in the next lesson, we will take care of load model to also get it into a dense state that really gets to the point of what your actual question is. All right. With a more cleaned up main function, it's time to get into the load model function. There is still much going on. So my first impression is still, if I have to understand the load model function, I'm trying to go through the lines, but I'm not really finding my way. So maybe you have an idea how to clean up this one.
Mm-hmm. This seems like a lot of leftover structure that probably has some sort of meaning in the original code. But in the example that we're getting here, it doesn't really seem to mean much. So we might just get from the understanding that we're talking about raising exceptions and how to have them bubble up, basically. That's like our understanding of the question at the moment. So maybe we go a little bit rough on here and take out a lot of stuff to make it just easier to understand.
Yeah.
First of all, I would take this nested if statement. That's like the quickest and easiest thing to take out.
Mm-hmm.
There's like two if statements on line 9 and now on line 11 that just give us different conditions for when load model should raise some sort of error.
Mm-hmm.
So we don't need this extra nested if statement. So we have this to happen now. And at this point, we're kind of like getting to the issue. I think we've maybe cleaned away enough that we're starting to see what is actually the issue with the code in relation to the question that this person had. And at this point, I get the feeling, they want the exception to bubble up. But what they're doing here is they're mixing up raising exceptions and also catching them with a try except block in the same context. Like they're doing this in the same function. They raise an exception and then right away catch it afterwards. This is somewhat of a mix-up of two different concepts.
Yeah.
It definitely took me a while to even just see that from the original state of the code.
I liked your little aha moment there, because that's exactly the moment that you want to have right away. You want a person to look at your code and be like, aha, okay, so I see that there is a mix-up of those things. Let me help you fix that. So basically, all the work that Martin has done so far is work that you should put into your question, but that not should your helper have to do until to get this aha moment to actually help you.
Yeah.
That's really nice that this happened. So this is now the point that we actually can go into the refactoring and into like helping what's going on there. But before we do, I want to address one last thing, which is important to note. We were saying before to have more generic names for your functions. So we renamed the predict raw function into the main function. We kept the load model one because it was a descriptive name. One thing why it might make sense to also adjust your code for your helper is not to make it just more generic, but also to remove any names that might be a security breach if you share them with the internet. So, for example, you write your code in your company and you're by contract not allowed to share code that you write while you're working for this company. So you have to try to abstract this question and the variable names and the function names as good as possible to make the example generic and not expose any information from within your company. Yeah, this brings us to the actual refactoring part. So now we have the code in a shape that created an aha moment for you. So you were saying in the former lesson, so now I understand a bit more what the issue here is. So maybe you can walk us through your finding.
I think I understand the issue right now, but I'm not sure yet at this point. From reading the question and cleaning up the code a bit, I can see that this person wants to figure out to see exception messages of an exception that gets raised in the stack trace of the main function. So an exception is going to get raised somewhere in load model, and they want to be able to see it when they run main. Basically, this is my understanding of the question right now. Then by refactoring a bit from top down, basically from the main function back into load model, we came to a point that it looks like they're confusing two concepts of raising an exception and then also catching it. And they're trying to do this at the same time, which will prevent the exception messages from bubbling up in the stack trace. So with this understanding, I now can see also that there's a lot of additional visual clutter by just talking about two different exceptions that this person is trying to raise and then catch. I can just get rid of one of them because it's not really relevant for the question. So I'm just going to get rid of one. I'm going to say, if source equals target, raise this error. And then what I just mentioned before, you don't want to mix these two concepts of actually raising and catching the exception. So I will take out the try and except from here and move it into the main function, because this is where you're probably going to want to catch this exception.
Yeah.
So I will say, try to load the model. And then if an exception occurs here, then you want to catch it. Well, actually, we can start by not catching it. Let's do that first.
Okay, yeah. To actually see what happens there.
I'm going to keep this code around because I think it's going to help us for refactoring later. But for now, the person really just wants to raise the exception. They don't necessarily want to catch it at all, or at least they don't want to catch it inside of load model, right?
Yeah.
So now, we have load model. I will take it out just so that we can see how visually clean we can make this example actually, right? And so there you go. We also don't really need supported anymore. So now we really just have a main function and then a function that gets called from the main function, and then some still cryptic X that's being passed in there that seems like to stand for source target, which we can refactor in a bit too.
Mm-hmm.
If I run this now, I'm not going to have any issue because source does not equal target here.
Mm-hmm.
So we're not raising the exception. But in the situation where these two are going to be the same, source and target have the same value, and I'm putting this into this dictionary that I created on line 13. Now, if I call this main function, then the error raises. We get the assertion error, source and target shouldn't be the same. And from my understanding, this answers the question that we had up here, because now there is a exception that occurs in the what he calls the subfunction load model.
Mm-hmm.
And we are calling load model in the main function, but the error message that got raised inside of load model appears here. Here you have the stack trace that happened by running main, basically.
Yeah, so this was basically the answer. So you remove the try except statements in load model so that the raise assertion error actually is not catched in load model. And in main, when you call load model and there is an error, it shows in the terminal that there is an assertion error. So later you might work with try except in main. But to summarize, the answer to the question is get rid of the try except blocks in the load model function.
Remove the try except block in load model. And then we could flesh it out a bit. So this is the how to do it. Basically, this is our answer, how to do it. And you said at the beginning, this is a how can I do it question. So this would be a quick and to the point answer to solve the issue that the person is facing. And then if you wanted to, like, why is this happening? Just because we're in an educational context here, I guess I would say something like, these are two different concepts. I guess in general, if you catch an exception, it's not going to get thrown and it's not going to appear in the stack trace. That's the point of catching exceptions. So if you catch your exception, it's not going to bubble up and it's not going to be anywhere in the stack trace.
Perfect. Okay, but let's not stop here. We also said that we want to do a little bit of refactoring. So in the next lesson, let's get into the code again and see how we can improve the code itself.